Greetings and welcome to the 2016 series of the Transforming Assessment webinars. Today's speaker is Chris Landorf at the University of Queensland in Australia, up in Queensland, where it's nice and warm. And our topic today is developing a four-dimensional interdisciplinary learning environment. So, Chris, would you like to begin, please?
I will, and fantastic to have everyone there on the other end of the line. I do have a fairly broad Australian accent. I'm not from Queensland, I'm from Broken Hill, so I will try and speak a bit more slowly than normal so you can understand me. What I'm going to do with this presentation is go through the background to the grant and what has led to us getting this particular money before I get into the actual website or the 4D learning environment. You'll see that it's actually called five-dimensional learning environment, and I will touch on that later. So if you'll bear with me, there is a bit of background. I'm also here on my own, so I'm hoping that if you do type things in that Matt can be prompting me. This is the first time I've done this, so I will appreciate a bit of prompt if people do need to ask questions. This is for construction industry students. Do you get more funding for more dimensions? If only. The other problem I've got is that this is done in PowerPoint and the various dot points I had kind of coming up as I referred to them. So Matt has talked me through how to use the little hand signal. I'm hoping that it'll be fairly self-evident as I go through. So a recurring theme in higher education is how to best achieve a balance between theory and practice and produce work-ready graduates. Certainly in the construction industry, this theory-practice nexus is complicated by the sector's very competitive and fragmented nature and the limited involvement of tertiary institutions in construction-related research. Let's this bit here. And this tends to result in innovations being retained as proprietary knowledge, so that they tend to be quite in-house for competitive advantage, while the generic body of professional knowledge remains fairly standardised and largely theoretical. I don't think this is peculiar to construction, but this is just painting the background for those of you that don't know it. Another particular issue with construction is, of course, the dangerous nature of construction sites. This further limits student access and the capacity to contextualise their learning through site visits. Jen, I'm assuming you can load download a copy of the PowerPoint at some stage. Move on to the next slide. So much has certainly been written in the literature about work-integrated learning as a means to address the application of disciplinary knowledge and skills in a real-world context, and that has certainly come to the fore with much larger classes that we're dealing with and trying to get students to have work experience. At a Higher Education Research and Development Australasia conference last year, Ferns and Russell reported that architecture students actually had the worst feelings of the 10 or so disciplines that they surveyed in relation to their work readiness. So architecture students really do have a problem with feeling like they are work ready. So tensions exist between the opportunities afforded by the workplace and the demands of placing large student cohorts in that workplace while ensuring that they all have an equitable learning experience and ensuring educational rigour. We at UQ did have at least a year out that students had to take as a mandatory requirement between their first degree and their professional master's degree, but had to remove that last year just simply because we couldn't guarantee them all jobs, and I think that's a fairly common issue. I know in the medical profession they seem to spend ages trying to get placements for students. So this would tend to suggest that there are opportunities for providing the benefits of work-integrated learning through simulated real-life contexts. What this webinar is going to do is present the development of an Australian Office for Learning and Teaching funded multidisciplinary four-dimensional digital learning environment for construction industry students. As I say, we have expanded it to the fifth dimension. So the construction industry's background to that, and I'm pretty sure the UK is not dissimilar, and I'm assuming New Zealand would be the same. I can't speak too much about elsewhere in the world. It's a significant sector of the Australian economy. It's the fourth largest contributor to GDP, so 7% of GDP. It's the fourth largest employing industry, approximately 9% of Australia's workforce. There are significant exports of particularly specialist consultancy services, so architectural and engineering services, and increasingly with varying degrees of success, we have had building companies that have tried to move in, and dare I point to Wembley Stadium in the UK as an example of that. And in general, the construction industry has a big impact on quality of life and sustainability through design, safe and livable and energy-efficient buildings and urban environments. It's also one of 4 sectors in Australia anyway with above-average workers' compensation claims and deaths, which is not really all that nice. So we've had a couple of recent studies of the construction industry. More recently over here it's to do with corruption, but there have been studies about the efficiency and effectiveness of it. And they point to some very fundamental flaws in the industry. And the Egan and Latham reports in the UK back in the late 90s or mid-90s started to point to this, and people started to question it. So we had a Royal Commission into the construction industry in the early 2000s that found similar things. It's a very complex and competitive structure. Projects tend to be quite transient. So unique projects, multidisciplinary, people are always moving on, so there's that knowledge transfer that isn't taking place. Very adversarial procurement methods, so you have the design team that tend to be facing off against the construction team, and people are trying new ways to improve that, but it seems to be a problem with knowledge transfer as well. This all tends to lead to this poor innovation, poor productivity and poor continuous improvement within the industry. This image behind here that you can see, guys, is actually taken from the 4D learning environment. In terms of the educational context, there was a fairly big study done here in 2007-8 by Michael Oswald and Tony Williams from the University of Newcastle in Newcastle here in Australia. That suggests there are some quite significant issues facing education for architects in particular, but construction industry professions in general. The curriculum is overcrowded and fragmented, so there's too much material and it lacks relevance and integration. It's very difficult for academics to maintain industry-relevant knowledge. Once you become a full-time academic, it's quite difficult to continue to work as an architect or an engineer or a construction manager. The technical demands or demands on courses in terms of their technical content has increased, but certainly not the percentage of coursework devoted to the technical courses. That has stayed relatively constant over the last 20 years. And interestingly, the issues around teamwork, there is now a big increase in expectations from employers about students being able to work in teams, but Oswald and Williams found that a lot of academics really don't quite know how to deal with this and how to integrate that into the way we teach. We certainly found that virtual 3D learning environments have been explored, and 4D virtual reality environments, but not what we term a real live building project that's been converted into 4D and 5D, as we are calling it. So this particular grant in December 2013, we had a project team representing architecture and engineering at UQ, construction management at University of Newcastle, and architecture at University of South Australia. And the figure was $220,000, which is, in our terms, a fairly major grant. So that's about, what would that be, about £90,000, that kind of figure in UK money. The primary goal was to provide a realistic, practical and multidisciplinary learning experience for a number of different professions. As I say, we had these various professions up here: architecture, engineering, construction management, and a second lot of architecture students at UniSA. What we started with, we had a fairly major building, and you can see it down here on the bottom right-hand corner. $130 million advanced engineering building, and luckily we got in just as that building had been approved and had started construction. And we had a very small internal grant here within the university that allowed us to hire a couple of final year students who were going at 1 to 2 weekly intervals onto the site and capturing photographs at various nodes around the site using a spherical lens camera. And they were stitching it together into a prototype 4D learning environment. And please don't ask me technical questions about that. I can give you that information if you want. But we had the students, and it was fairly easy for a couple of final year architecture students to get onto the building site. We liaised with the contractor, and they would set the camera up and take a series of photos around the site. So it probably took about an hour to an hour and a half each week to do that. And then it would take another hour and a half for them to actually download those photos, stitch them together, and actually place them within the 4D learning environment. And we'll come to look at that in a minute. So we had this 75 surveys, so 75 weekly surveys taken over the course of construction when we applied for the grant and we received the grant money. In addition to that, what we were intending to do was to add interviews, so that's the oral, and pedagogical resources to the environment. And it's this oral issue that becomes the fifth dimension in our terminology here. So a series of interviews that we're actually will have yet to upload into the 4D learning environment with various members of the construction team, the design and construction team. So the learning environment concept, and here I'll run through our various dimensions. So we've got all what we refer to as one-dimensional information. So all of that contractual information that goes with any major construction project. So requests for information from our contractor to the architects instructions back to the builder, variations in the price, notices of delay, so a whole variety of things. And this is the area that I teach, is contract administration. So there's a lot of that documentation that is sitting there in the background that students don't generally get access to. The second dimension, of course, are all of our construction drawings. And so these are the two-dimensional construction drawings that the builder then turns into, obviously, our three-dimensional building. And right up the very top right here we have what would be referred to as an artist's impression, but it's really a CAD drawing, 3D CAD drawing of the building. So there are our two dimensions. Our third dimension were the problem-based learning exercises. So these were the things that were probably the hardest thing for the research grant team to get their head around, is just how we were going to use this resource and get students to engage with it in the best possible way. What we've ended up with are 6 different case studies of how the learning environment was used. The 4D environment, of course, is the 4D virtual tour, so that's all of our photographs stitched together, and unfortunately I won't be able to show you how to fully use this, but the links are there and you can get in and actually wheel around in it yourself, but I will try and show you how to use it. And of course our fifth dimension here is design and construction team interviews, which we're finalising now. So that was kind of how we laid it out in conceptual terms, and things changed a little. We were going to develop our problem-based learning exercises by running a series of workshops with people in practice, but decided that we'd be better off perhaps not doing that, but we could actually liaise more indirectly with practice to develop that, and we added the interviews to the grant. So we didn't run workshops with the profession to develop these problem-based learning exercises, but we did get a series of interviews. If I'm correct, there was a related... What's that, Matthew? Sorry, are the case studies available too? Yes, they are. But the case studies are available through the project website, not through the learning environment. So now the website itself. So down the bottom here is the link, which will actually get you to this particular, if you can look at it, this is kind of what it opens up like. So what we have in front of you here are two different surveys. The 7th of June 2011 and then the 28th of February 2012. You can see the difference. So both of these are taken looking generally in the same direction, and it's this building in the back here which you can see is the anchor. This one is obviously taken from outside the building site, and this one is taken from within the building site. And this became a bit of an issue as the project developed, and if we get to do this again, we will change the way we do it so that the nodes don't vary quite as much as they did. You can see why, that this one here was taken outside the building site as the building erection commenced and the building got up out of the ground. We had all of the scaffolding around it, and you couldn't use the same nodes to take the photos. If we move on to the next slide, what we have here, I'll just go back. So this particular slide here is now located here. So we're still looking at survey 33 on the 28th of February. And what you can do is actually hold your finger down, or you can click on the site, so you can put your finger on it and turn with your mouse, and the view will rotate. So you can turn it around, and so what we can see is, if I can point at the builder here, he's actually off to the very left-hand side of this slide here. And all I've done is clicked and dragged on the slide and rotated it around the site. So you can do it in the full 360 at the horizontal level, and you can actually move up and down 360 degrees vertically as well. So when you start using the site, it actually can make you feel a bit ill if you're a bit too quick with it. What you can also do with it, and again we have our standard shot here, but we can zoom in with it. So that does enable students to zoom into various details, and you can see here, you can point at the beginnings, the starter bars for a column with the caps on top. You can sort of zoom into the cradles being used to set out the reinforcing and the cabling underneath those cradles. It is a 360-degree image on the live site. It is a 360-degree image on the live site. So sorry for me pausing and reading. I really can't do two things at once, actually. So what we have here now is Survey 3, Level 2, Node 6. So along the bottom here is a bar that you can drag that will move you from Survey 1, 2, 3 chronologically through the building process. So you can see it's linked at that point there. We're looking at Survey 3, and way over here it's linked that should be reading 33 down the bottom there, but that's just drag that along. Takes a bit of time, but eventually you'll get Survey 33 will come up in the view there. Hang on, sorry, I'll just go back to that. This here is where we move between levels, so you can see this is sitting at level 2 very early on in the process, and by the time we get to February 2012, we're moving up to level 7. It was a seven-story building, and this is actually taken on level 5, that particular view of that survey. The other thing to draw attention to here is that little mini-map in the corner. Students, you can double-click on that and it will actually enlarge to a much bigger kind of view, but you can probably barely see here that there are a series of nodes on that floor plan, and that's how you navigate around the floor plan. So you can navigate up and down the floor levels, chronologically through the building and around the building site. The other thing that we have integrated into the that we now have integrated into the site are a number of learning resources. So we have this drop-down menu at the top here, and we've developed a number of limited views. We have a lot of documentation that has been uploaded into it, and links to other media. We now have 3 time-lapse videos that we've got loaded into the site. and the interviews will eventually go into there. So if we just look at the documentation menu here, what that does when you click on that is it will pull down a variety of things through here, and you can have the whole of building. You can just look at drawings related to the facade. So we figured that there was a big auditorium, an atrium space and a facade that were major aspects of the building. So we've tried to isolate drawings and surveys that relate specifically to that. What we also have through that drop-down menu is access to all of the various drawings. So as you can see down here, what I've done there is I've clicked on that drawing. We get a pop-up box that says this relates to wall sections, and over here you can actually click on this here and it will call up the drawing. Now this for me is an amazing resource, because while we're talking about BIM and being able to do this in 3 dimensions, at the moment students still have to be able to read 2-dimensional drawings and produce buildings in 2-dimensional drawings. That is changing rapidly, and that's probably the next step for this particular 4D learning environment, is how to integrate that 3-dimensional information. This building is a reasonably large building and reasonably complex as well, but the construction and design team did not use a full 3D BIM model. The architects used a version of a BIM model, the engineers used a version, but they really couldn't bring it together as a full BIM model. So for those of you that are into construction, the BIM model is building information modelling, and the dream is that all members of the design consultancy team will be working on one computer-aided design 3-dimensional model. And the power of that, of course, is that you get people working together, and it will really allow you to problem solve things like clashes of construction services and structure well before you get onto the building site. All off the same plan. Solar panels on level 8 too. Yes, there are solar panels on level 8. Now the videos, this would have been nice to show you, but I hope some of you will actually get in there and have a look at these. So we have time-lapse video, and you can see on the left-hand side here, this is the beginnings of it, and this is a short while later of the auditorium. And the auditorium is quite an impressive construction element. The roof was built at ground level, trucked in. It was actually built in sections, so these truss sections were built off-site, brought on-site. The whole thing was put together and then lifted up into place, and it was quite an innovative way to do it. So we have a video of that, and we have this time-lapse video here, which is actually showing cranes and people moving around, and you can see this is later in the day. So we've got these erected at this point, but nothing erected down here. And later in the day, we see these erected, and these have gone in as well. So it was just a camera set up there taking still shots over a period of time. So there's a fair amount of, fair number of resources attached to the learning environment. So this was roughly the methodology. We were trying to develop something that could be used across disciplines, so we all sat down together as a team of researchers and developed our own way of using it, trialled that with students, and then looked at the various successes or otherwise of it. So the early stage was just development. I tested it at the usability trial stage with my 3rd year technical, architectural technical course. It was used at the 3rd stage by construction managers and the architectural 3rd year course at UniSA. I used it again here, and so did the civil engineering 2nd year students here at UQ, and 1st year construction management students used it as well. Back here at the pilot stage, it was also used as a demonstration tool. So those of us on the project grant team here and here were using it. Sorry, here and here, we were using it as part of an assessment exercise. but we also had a first year construction management course that used it just as a demonstration tool in face-to-face lectures, so it proved to be fairly flexible. And here's a list of the various groups that we trialled it with. As I say, this group was just self-directed learning resource. The engineers, it was just a self-directed learning resource. So when I say that, the lecturer introduced it and showed students how it could be used. And then in this case, it wasn't assessed. In the case of the engineering students, they had to produce say a learning journal about it. The rest of us were really more directed about how we got students to use it, and I'll show you that in a minute. I used it here with my contract management students more as an in-class tool to contextualise the sorts of problems and issues that I was talking about, but I wasn't assessing it with those guys. So I'm just going to run through the results for the two architecture courses because they're probably the most comparable. So semester 1 last year, which is, what dates are that? That's sort of late February through to early June in our semester here. It was trialled by third year Bachelor of Architecture students at the University of South Australia. Stephen Ward had students working in pairs on an accessible activity, and he posed this particular question. So how does technology affect the design concept of the building? So we're trying to get students to think not of air conditioning, lifts, lighting as separate to the design, that it's all part of a design process. Stephen said to use annotated screenshots, plan sections to communicate these 4 things. So observations of design, looking at the location of movement of services throughout the building, which is fantastic because people, the students, it's not covered up in this thing. They can actually get into the early stages of the building process and see it, see services being developed over time. And this was the feedback we got from students was that this is quite advantageous compared to a standard site visit where you might go once or twice over the course of a building project. They could go back repeatedly and they could track the process over time. So, yeah, all right. And the sort of results that Stephen got. So up the top here we see a response of students to just the observations about how technical issues impacted on the design. Construction sequencing, this was a very successful way of using it. Mind you, what I'm showing you here are the best students, the product from the best students. So graphically they're having to present the material, but they're also having to get in and look quite seriously at what's going on, do some research and make some comments about it. Stephen used it in terms of the building code, which I also used it when I trialled it with my third year students. I used it for that because they've used some non-standard solutions, some deemed to satisfy solutions in the project, which is quite interesting. And this will become very powerful, or a very powerful tool when we get the fire services engineer involved. So we will have an interview that we will be able to use in lectures to explain what is going on. And in terms of sustainable design. So those of you that are not familiar with Queensland has pretty mild winters, to say the least, and very hot, humid, well not very hot, but fairly hot, humid conditions in summer. So air conditioning buildings is slightly different to how you'd see it in cooler climates because of the humidity. I trialled it in semester 2 of last year, which is from sort of late July through to November. Again with third year Bachelor of Architectural Design students in an architectural technology course. Okay, Jeffrey, you're asking, did students have any examples of how they could use it for assessment responses? No, in short response, no. We do now have the examples though, so I would expect the next lot of students to do even better once they'd seen a couple of examples. I had them working in teams of 4, and this was, I guess, the power of the tool, that I was working the particular course that I was running was a major aim of that course was to get them to work in teams and to reflect on that teamwork. So they had to produce a team contract in the very beginning of the course and to reflect on how they performed against that contract as they progressed over the course of the 13-week semester. I was using, unlike Stephen Ward in the UniSA example, where he was using it as an in-house kind or a face-to-face teaching tool, as a demonstration tool, and then students would go away and interact with it. I was being more directed using in-class scenario-based observation activities. So an example would be me saying to students, your director has just walked back into the office and asked you to go down and have a look at a certain thing on site. Can you access survey number 31 and have a look at level 7 and see if you can see X, Y, and Z, and then to comment on it. So I was looking specifically, that's the Building Code of Australia. So these various things are covered in that. I was looking at structural systems, and again we have the structural engineer interview, which we'll be able to add to this this coming year. Environmental systems, which is a fairly major part of the teaching process now in architecture. And I was quite interested in construction systems, and students struggle to understand the difference between structure and construction. So these are the the windows and the glazing elements, the screening, sun screening elements, that kind of thing. So the sort of results I had the advantage of being able, if I can just click back to that, I could show my students these examples from Stephen Ward's UniSA students, which meant that I actually, that the ante was upped with it. Once I had an example, students understood what was required and that it wasn't a trick question. So if we look up the very top here, they're starting to analyse where the fire stairs are in the building and how people are expected to get to them, the sorts of distances between them. They're looking at toilets, those sorts of amenities are a big part of the building code, where fire hydrants are located and the reach of those sorts of fire hose reels around the building. So these students would go in and they were more directed in their observations, and I could have done so in a face-to-face lecture. Construction down the bottom here. So they're actually starting here to look at how things are put together, which for me was very useful. What wasn't useful was the fact that a lot of these students are very good at the internet, of course, so what they were doing was roaming around the internet and pulling off a lot of these sorts of drawings from the internet, rather than looking at the 2D construction drawings that we had attached to the learning environment. So this, to a degree, makes it a lot easier for them. If they're having to look at the 2D information and then interpret that and to reflect on it, it's much easier to gauge their understanding. Repeating this kind of information from the internet is not really proving that they understand it. So how we get around that, I don't know, but some of the drawings I'd like to think students would be producing, but at this particular point, no, they're going straight to the internet and downloading it from there, which is a bit disappointing. We had a very simple questionnaire that we distributed to students. It was just asking them five questions. There were 4 like-it type scale responses, and then open-ended questions attached to 2 of them. The results, particularly in relation to enhancing the student learning, I'm not going to go through them all, but the first question related to appearance. Did you like the appearance of the learning environment? Now, if you remember, I trialled this twice with my third-year students, once in 2014 and once in 2015. And the impact of the 2014, we actually did quite a lot of work to enhance the look and appearance of the environment. And responses to that were actually a lot better in 2015 than 2014. The second question related to navigation. Did you find the learning environment easy to use? And again, the improvements that we made on the first prototype in 2014 were reflected in the student responses. I'll talk to that in a minute, Jeffrey, because that's a very good point. Understanding. Did you find the learning environment assisted your understanding of architectural technology? So that's what we're looking at here. And you can see that by far the students at both universities felt that the learning environment did actually enhance their understanding of the construction process and architectural technology. Despite the appearance of navigational issues, the positive impact of the learning environment on technical understanding was almost universally supported. Some students commented that it provided more information than two-dimensional photographs or ad hoc site visits. It was useful to see the way the site was organised, truck turning circles, crane locations, general logistics, and I'm reading student responses to this. Question 3 had an open-ended response to it. It enhanced understanding of construction sequencing, and some students made the comment that it would be great to actually have videos of some of the key processes. So in part, in response to your question down there, Jeff, I'd love to be able to film people actually pouring concrete, the guys fixing steel, those sorts of processes would be another layer that we could add to this environment. Revealed the building structure and the implications of architectural detailing, while the Zoom feature enabled valuable close examination of particular details. Some students commented on the usefulness of comparing construction drawings and digital images in the learning environment. The suggestions for improvement included the incorporation of time-lapse videos, which we've done, but on top of that, the time-lapse videos of key construction processes to help bridge between the 1 to 2 week gap. So it's those key processes that I think would add another layer to this that would be very, very valuable. Question 4 was simply, did you find the learning environment enhanced the architectural technology learning experience? So the previous one is just relating to enhancing their understanding. This is the learning experience. We find that construction, because of the issues I mentioned at the very beginning of this session, because it is quite hard, there's no standard textbook to teach from, students find it quite hard to understand architectural technology and tend to treat it as a separate exercise to the construction, to design. And we're trying to actually make them see it as fun and an integral part of design. So the sort of responses you can see here, again, it's overwhelmingly in favour of this environment being able to enhance the actual learning experience. Some of the student comments, concepts explained in lectures were easier to visualise three-dimensionally. Instant classroom access was a positive, so a lot of my students were accessing this in the class as I was using it. Group discussion was facilitated. This for me was a fantastic victory because I was setting exercises where they had to work in teams to solve problems. And students actually said that it facilitated and enhanced their understanding. Some suggestions for improvement here included more defined learning tasks with clearer aims and a more direct link to assessment, so we still have to improve that aspect of it. And students generally felt the site provided a good visual aid, but a more direct teaching approach would improve learning and prevent students getting lost. Guided tours were suggested, and probably the most useful comment that we had from students was that an introductory learning tutorial would be a very useful way to develop this, and I've just received a small grant here to help develop this even further with our engineering colleagues, so that we can introduce students to a brief tutorial that will actually give them the terminology, a very basic construction, objects, processes, and elements, steel column, reinforcing cage, this kind of stuff, because the second year students in particular in civil engineering just didn't know what they were looking at, basically. So the aim is to develop this so that we will have a series of tutorials that students can work through with pop-ups. So as students point at particular things, a pop-up text box will appear and say this is a still column, this is a reinforcing cage, etc. So that was one of the particularly good things that came out of the student comments. The fifth, as I say, it was a four-part questionnaire. The fifth part was just a standard question about other suggestions to improve the learning environment. So I'll move on to just wrapping it up now in terms of my blabbing. So as I have explained, work experience has had a particularly long tradition in professional education, not just construction industry, but certainly the medical professions, teaching, a whole variety of those sorts of professions. We rely on trying to give students this hands-on work experience. The complexity of the workplace, student numbers have impacted on our capacity to actually place students in these environments and to give them an equitable and rigorous kind of educational experience. And there's certainly opportunities, we feel, for this type of learning environment. It can be used as a simple demonstration tool, so I've stood up and used it just to point at things in a class, or you can spend more time to try and develop team and problem-based learning exercises that will guide students through the learning environment. And it's still fairly hard to do, and we're still improving on that. What we sort of concluded out of the whole exercise is that the thing does actually provide quite a flexible platform for curriculum development across a number of disciplines and a number of year levels, so that was quite pleasing. It seems to have had a positive impact on students' understanding of the construction process. In response to Jeff's question down the bottom there, it would be enhanced by the inclusion of additional case studies, and certainly the tutorials we're going to try and add to it with the additional case studies. So we're looking at residential scale buildings as well as more buildings of this scale. A high-rise building would be fantastic. It could be extended to other construction-related disciplines, and I also think that this particular thing could be extended to a number of other professional-based education disciplines, including the medical professions, paramedical. I've seen something like this that's being trialled for teaching, and we've got someone else here who's looking at tourism and hospitality for this kind of thing. The big thing I think that this could be further tested in relation to is its impact on critical thinking and work readiness. I haven't quite worked out how to assess that. Yes, thank you, Matthew. Civil, yep, mining. The capacity to integrate 3D laser scanning technology, and certainly the capacity to take 3D laser scanning technology into a virtual reality environment, and that can be done. We had students who commented about this saying, oh gee, it does look real, doesn't it? Because they thought it was all a virtual reality environment, and other students who couldn't work out why they couldn't walk themselves through the photos, because they thought it was all computer generated. So I need to get my head into the way they think about these things, quite obviously. Now, getting back to your question earlier, Jeffrey, about what this costs, I'm working with a colleague in the UK, hopefully trying to add another UK case study, and we're thinking that the building we're looking at is about the same scale as the one we've just done here in Australia. And we're thinking that about £20,000 would be enough to hire the students to take the weekly shots and put them into the 4D virtual environment. So that's kind of the figure. We have a guide, a technical guide at the moment to the sorts of equipment that we used and how to set it up and how to import the photographs into the 5D environment. So the software environment is reusable. Yes, it is, Matthew. It is reusable. It's code that we've generated, not me personally, but we do have someone who has been developing the code for it. But it certainly is reusable. So the idea of getting this out there is really to look for other case studies, try and get enough money to have people actually record these case studies. But I also see another stage of it being able to walk onto sites with 3D laser scanners and being able to import that into virtual reality software. So we can have the same chronological move through a building over time, but students can actually walk themselves through the site. So Matthew, that's all I have to say.
Brilliant. Thank you, Chris. That's wonderful. I'm not sure if people quite remember, there was a session last year that the University of Melbourne developed a sort of a 3D tour style system where they did use the 360-degree images, but they had little hot points on the image where you clicked it and you'd be able to jump to the next image. They also had the map system as well, but yes, it seems that there's one or two of these sort of style systems popping up around the place. So definitely the way of the future.
It's still a bit rough around the edges, but we're working our way towards something that's a bit smoother and perhaps something that's a bit more uniform.
Very good, though. Very good, nevertheless. Folks, whilst you're thinking about questions to ask, if you would like to fill in our feedback survey, that would be very much appreciated. I'll just pop in the link to that. But please write your questions into the tech chat as we still have some time. This link to feedback. But yeah, more questions, please.
So Jeffrey has just wondered if assessment questions could be integrated into the images. That is a whole other area, isn't it, where you could use it as a multiple choice kind of exam environment almost, or a student self-test environment. So that's something that's kind of in the back of my head, is to be able to capture some of these images and to use them to test student knowledge in a formative feedback kind of manner. I think that's a great idea.
Jen also asked, is the technical guide freely available? Yeah.
We've just submitted we're about to submit our final grant report, Jen, and that will be available through the project website. So it's the 4D construction. Now you've got me. I need to.
Actually, that's Matthew, the same website that we put up earlier, isn't it?
It's a 4D environment project website.
Is it this one? The one I've just pasted in. 4D construction, youtubecloud.net/virtual tour, blah, blah, blah. Is that the one?
No. 4dconstruction.architecture.uq.edu.au. So we have the 4D learning environment, and then we have the actual 4D construction project website. So, Jen, if you get yourself into the 4dconstruction.architecture.uq.edu.au, you will come to the project website, and down the bottom of that you can actually access the 4D learning environment, the various case studies, and we will be adding other resources such as the technical guide there, so it will be freely available, yes. What else we got, Sally? How best to integrate assessment? Oh, Sally, yes. It takes a lot of thinking around it. Because you have to guide students without giving the game away. We had the construction managers used it really as just a contextualising trigger. Graham Brewer at University of Newcastle went through the various minutes of site meetings, for example, and picked a particular element that was over a series of site meetings. I can't remember what it was now. Supply of the timber, I think, in the auditorium, and of course they ordered it too late to get it supplied on time because it had to dry. So he chose that as a particular question: what would you do if this happened? And students had to then go through the various site meeting minutes to look at what happened and suggest alternative approaches. So that was one way of it being used. I've just showed you how we used it in architecture. I think Jeff's idea of using it as a self-testing environment for students is a good one. So it really can be used in a variety of different ways, but it does take a bit of thinking. It's a great resource, but you've really got to think about how you're going to use it. Could you get the computer to do, yes, more authentic testing? Yes. I agree, Tim. Thank you. That's fantastic. Yeah, and that for me is a whole other, because I'm not particularly computer literate, but it really needs me to pair with someone who understands how to do that kind of stuff. But I think that's great. Excellent. Thank you. Yeah. Okay, Matt, how are we doing?
We're doing very well. Any other questions, folks? If anybody would like to ask a question via the microphone, they're welcome to do that as well. Just use the little hand up symbol there at the top of the participants list, and we'll know you want to ask a question.
I'm certainly open to you emailing me. I don't know if that's appropriate, Matt, but I understand that questions will arise if you actually get in there and start to think about how you might use it.
Chris, do you want to type your email address into the text chat, and then people will be able to contact you? I can also I'll stick a link to your UQ Research's homepage so that people will be able to track you down too.
That would be great.
So when I put this session is being recorded, and it will be published on the Transforming Assessment website, along with a copy of the slides, the text chat log, and some links to the various bits of the project. So the virtual system and the project website as well.
I've just noticed Jen has asked, wondering how long it took to set up. It was actually quite a long time. We had to, once we knew that the project was going ahead, as construction projects take a long time, but we then had to organise a couple of students, made sure they had their construction training, introduce them, get the builder buy-in. The good thing about the University of Queensland, we had a very good property and facilities department who were on board with it, and a cooperative builder. And then once they got going, it was fine. The whole 4D learning environment is actually based on something that Professor Ian Cameron in chemical engineering developed here. But he was looking at chemical processing plants, but he wasn't looking at it over time. He started just by photographing images of a processing plant and doing walkthroughs for students with pop-up sort of questions and responses in it. So that was part of work that dated back to 2009 from memory, and he's continued to develop it. So Ian was the one who said, we're building this big new building here at UQ. Is there anyone interested in coming in on a small university grant to get funding to actually photograph it? And that was when I got involved. So it's taken quite some time, and Ian certainly did the groundwork. He's the godfather of the 4D learning environment. Oh, excellent, Sally. Yeah. Ian's fantastic. He's a genuinely brilliant kind of educator. So that's good. Yeah.
Okay, thank you, Chris. I think we'll wrap it up here. It's 5 minutes to the hour, but people are welcome to stick around and still ask questions if they would like. But I'm now going to stop the recording, so just formally thank you, Chris, for your very interesting and engaging session.
Thank you, everyone. I'm delighted to spread the word, and please get in touch. And thank you, Matt and Jeff, for the opportunity.
You're most welcome. Okay, bye-bye all.